Hey guys, today's topic is Rhombi, Rectangles, and Squares, Unit 4, Day 3. Our objective is that you can identify properties of rhombi, rectangles, and squares, determine missing angle measures of rhombi, rectangles, and squares, as well as determine their area. The first shape we're going to talk about today is the rhombus. And one way to remember what a rhombus is to imagine that you are squishing it. All right, so if we put down a bunch of pressure kind of at a sideways angle, you can imagine that it will squish over to the shape that you have on the right. And that's what a rhombus is. So you know that squares have 4 congruent sides, and that wouldn't change when you squish it. So you'd still have 4 congruent sides, but now it wouldn't have those 90-degree angles anymore. Similarly, if you think about diamonds, like from a deck of cards, they're the same shape as rhombi. The definition we're going to be working with, though, is a kite/parallelogram with all congruent sides. So one way to think about it is like if a kite and a parallelogram had a baby, it would be a rhombus. Okay? Now, there's a couple of properties about rhombi that we're going to go over. First, like we mentioned above, all the sides are congruent. And we can show that by using these tick marks. Second, you know that the opposite angles are congruent. And we know this because a rhombus is a parallelogram, and that's one of the properties we know about parallelograms. So angle A and angle C would be congruent, and then angle D and angle B would be congruent. We also know that adjacent angles are supplementary. So angles that are next to each other would equal 180 degrees. For example, angle D plus angle C would equal 180 degrees. We also know that diagonals bisect each other. So if we draw the diagonals from A to C and from D to B, they bisect each other, which means that from the center point to A is the same as from the center point to C. Similarly, from that center point to D, it is the same distance as that center point to B. They also intersect at a 90-degree angle. And so if we put property 4 and 5 together, we know that their diagonals are perpendicular bisectors. And then lastly, any other properties of parallelograms, kites, trapezoids, and quadrilaterals also apply to rhombuses. In order to find the area of a rhombus, because they're both parallelograms and kites, you can use either formula depending on whatever information is given. Just keep in mind, if we're talking about a rhombus, you still need that vertical height. So you still need to figure out what this height is and not the slant height. All right, let's go on to our first teacher example. Here we need to find the measure of angle C given this rhombus. So we already know all of these are going to be congruent. I know that D and B are congruent. I know that A and C are congruent. And then I know that angle C plus angle D are supplementary, so equal 180 degrees. Angle C plus 50 equals 180. And then when I'm solving, I get the measure of angle C to equal 130 degrees. Take a little bit of time and try your first student example. Now, the second teacher example asks us to determine the area of this rhombus given that ST is 4 centimeters and that PR is 12. Here, I am given diagonals, so it would be worth my while to use the formula with diagonals, right? Because I don't have the base or the height for any of these, so it'd be a lot more work to try to figure that out. Now, since only ST is 4 centimeters, but I know that the diagonals bisect each other, I know that ST is congruent to TQ, which would make that also 4 centimeters. Reading what is written very carefully, I know that the entire diagonal PR is 12. So, diagonal 1 is 8 centimeters, which is coming from 4 plus 4. Diagonal 2 is 12 centimeters. So if I'm going to use my area formula, 1/2, 8 times 12, area should be 0.5 times 8 times 12, 48 centimeters squared. Take some time to try student example number 2. Now our second shape is a rectangle. Just off the top of your head, draw a rectangle. Most of you know what a rectangle is. Probably something like that is what's on your paper. The teacher definition is that a rectangle is a trapezoid / parallelogram that only has right angles. So again, if like a trapezoid and a parallelogram were to have a baby, you would end up with a rectangle. Now the properties of rectangles, opposite sides are congruent. So we know that this side is the same as this one, and this one is the same as that one. We also know that adjacent angles are supplementary, which makes sense since they're all 90 degrees. So 90 plus 90 will always equal 180. We also know that the diagonals bisect each other. So let's do it in red. Diagonal here and my diagonal here. I know that all my diagonal halves are congruent. I also know the diagonals themselves are congruent. So if we're thinking this is A, B, C, D, we would be able to say that segment AC is congruent to segment BD, so the BD. So the entire diagonal here is congruent to the entire diagonal here. And then any other properties of parallelograms, isosceles, trapezoids, and quadrilaterals would also apply to a rectangle. And the area formula for a rectangle is just base times height, same as what they were for parallelograms. Here it says to determine the angle measures and area of the rectangle below. Hopefully the angle measure is very obvious. They are all 90 degrees. That's always going to be true about rectangles. The area formula for rectangle is base times height. And here my base is 84 and my height is 50. So when I do area equals 84 times 50, I end up with 84 times 50, 4,200 feet squared. And take a second and try student example number 3. And our last shape is square. Try and draw a square. Hopefully you can imagine and draw a square pretty easily. All right, the teacher definition that we're going to be working with in terms of a square is a rectangle / rhombus with congruent sides and right angles. That means all 4 sides are congruent. We also know opposite sides are congruent, and this is a parallelogram property. Second, we know that adjacent angles are supplementary. Again, they're all 90 degrees, so 90 plus 90 is 180. We know that diagonals bisect each other. So if we draw in our diagonals, from the center. We know they bisect each other like that. We also know that the diagonals themselves are congruent. So again, if we went A, B, C, D, segment AC is congruent to segment BD. They intersect, the diagonals intersect at right angles, like that. And then any other property of rhombi, rectangles, parallelograms, all of those apply. And the way that you find the area of a square is base times height, where B is the base and H is the vertical height. So here we have the sides of a square that are represented by the following equations. (3x plus 12, 5x minus 2). We know that all your square sides are congruent. Therefore, we know that 3x plus 12 equals 5x minus 2. I'm going to add 2 to both sides. 3x plus 14 equals 5x. If we subtract 3x from both sides, 14 equals 2x. We get x equals 7. So try student example 5 on your own. Alrighty, now take us a little bit of time, 3 to 5 sentences to write your summary. Make sure you're including the objective as well as using the correct academic vocabulary. See you in class.